In 1967, scientists on planet Earth made a startling discovery. Someone was sending us signals through space. Were aliens trying to send us a message?
When pulsars were first discovered, they blew us away. Something in the night sky was turning on and off. How could something in nature do that? And so we actually called them LGM objects, that stood for little green men.
Astronomers in England detected the signals using a primitive radio telescope, a massive array of poles and wires stretched out over 4 acres of land. The first of the signals was not just an isolated peak in the radio noise. It was a regular blip, precisely repeating every 1.3 seconds. Within a year, though, scientists realized aliens were not behind the regular signals. Instead, they came from rapidly rotating stars. Pulsar became the catchy name for the new phenomenon, short for pulsating star. A pulsar seems to blink on and off because the rotating star is sending out beams of energy from its magnetic field, which is not aligned with its axis of rotation. We see the beam as a flash of light when it passes across our field of view.
The beam coming out of a pulsar works a lot like this emergency beacon. Now take a look at how it flashes. It's not just blinking on and off. Inside the housing, the beacon has a rotating reflector that sweeps the light around 360 degrees. As long as we have line of sight with the beam, it sweeps by us every time it goes around. But it looks like it's flashing on and off. A rotating pulsar looks like it is flashing on and off for the same reason.
But a pulsar isn't just any kind of rotating star. It's a rotating neutron star, an exotic object created when a big, massive star ends its life in a supernova. The crushed stellar remnant becomes the neutron star, with a mass 1.4 times our Sun, reduced to a sphere the size of Manhattan. It is one of the most bizarre objects in nature.
You have to understand that a neutron star is matter barely holding up before it collapses into a black hole. The gravity is so strong that it has crushed electrons into the nucleus of an atom and made neutrons. It's amazing.
If you take something like a sugar cube, for example, about a cubic centimeter, if this sugar cube were made of neutron star material, it would weigh close to 1 billion tons. Think of it as something like 8,000 aircraft carriers in something that size. Incredibly dense objects.
The newly created neutron star can't help having a high-speed spin.
All stars that we know about are already rotating, so when a massive star compresses into a neutron star, the rotation is compressed also. It's just like an ice skater. When an ice skater spins and she pulls her arms in, she spins faster.
The spinning neutron star is a massive natural electric generator. Its spin creates a powerful magnetic field. The magnetic force grabs onto electrons and other atomic particles and flings them into space at high speeds. High-speed particles always emit radiation, and in pulsars, they're coming out in beams. These are the pulses we see, but we see them only when the beams are pointed in our direction.
How many pulsars are known? It's something over 1,800, and the number is growing rapidly because we continue to discover new pulsars all the time. But the number of pulsars that exist, and these are all found in our galaxy, the Milky Way, is many, many times larger than that, because the beams that are seen in radio primarily are very small, and so we only see a tiny fraction of all the pulsars that are out there.
But each pulsar has a completely different rotational speed. The slowest rotates once every 9.437 seconds, and the fastest goes around 716 times every second. If we stood on its surface, we'd be going more than 97 million miles per hour. That's about 10 million times faster than we travel on Earth.
Every pulsar has an absolutely unique spin. It goes around at a given rate, and that's just like a fingerprint for an individual. So if you know what that characteristic spin is, then you know what that pulsar is.